Hello everyone and welcome to this video on the Python programming language. So in this video, we're going to attempt to create a program that optimizes a user's portfolio. Now, currently I'm on Google's website called colab.research.google.com because it makes it really easy to start writing Python code. So you don't have to install Python onto your computer. You can just go to this website and then log in using your Google account and get started writing your Python code. So let's go ahead and get started writing this Python code. So the first thing that you're going to want to do is click on File and then click on New Notebook, where a new tab will open up for you, and then a new cell will open up for you. Okay, now the first thing that I like to do before I write any logic for my code is to put a description and comments in the first cell. So I'm going to do that now. So this program attempts to optimize a user's portfolio using the efficient frontier and Python. But that's kind of a given, right? All right, so let's go ahead and create a new cell by clicking this code button in the top left. And I'm going to import some libraries. Okay, but you know what? Before I import these libraries, I should probably explain to you all what portfolio optimization is. And this definition is coming directly from Wikipedia. So portfolio optimization is the process of selecting the best portfolio out of the set of portfolios being considered according to some objective. And the objective typically maximizes factors such as expected return and minimizes costs like financial risk. All right, just so you all know what we're doing here. All right, so let's go ahead and continue and import the libraries that we need. So from pandas underscore data reader, I'm going to import data as web. Next, I'm going to import pandas as PD, and I'm going to import numpy as np. And then from datetime, I'm going to import datetime. And next, I'm going to import matplotlib.pyplot as plt. And then we're going to give our plot a style. So just type plt.style.use, and I use the 538 style quite a bit. I like it. So let's go ahead and run this cell by clicking this button here in the left, and hopefully we have no errors. All right, so that looks good. I'm going to scroll this up a little bit. Let's go ahead and create a new cell. And now I'm going to get the stock symbols or tickers in the portfolio. So I'm going to create a fictional portfolio, of course, and I'm going to let you all know that this whole video here is not financial advice. All right, this is just going to be a fictional portfolio that we're going to look at and try to optimize. All right, so I'm going to use FANG, F-A-A-N-G, and FANG is an acronym referring to the stocks of the 5 most popular and best performing American technology companies. So that's Facebook, Amazon, Apple, Netflix, and now Alphabet, which was formerly known as Google. So let's go ahead and create a variable called assets and set it equal to Facebook, Amazon, AMZN, Apple, AAPL, Netflix, NFLX, and Google, GOOG. All right, so we have the symbol for Facebook, the symbol for Amazon, the symbol for Apple, the symbol for Netflix, and the symbol for Google. All right, so let's go ahead and run this cell, and let's create a new cell. All right, now in this cell, we are going to assign weights to our stocks here, or to our portfolio. So we're going to assign weights to the stocks, and the weight must equal 1, right? Because it's going to be a percentage of our portfolio. So all of these stocks in our portfolio need to add up to 100%. So I'm going to create a variable called weights and set it equal to np.array, and we're going to put in an equal amount of weights for each of these stocks. So we could just do 1 divided by 5 because there's 5 stocks in our fictional portfolio. So it'd be 0 0.2, 0 0.2, 0 0.2, 0 0.2, and 0 0.2. All right. So we have right now 20% of our portfolio is in each of these companies. All right. So now let's go ahead and run this. Okay. And let's create a new cell. And now I want to get the stock's start date, or maybe I should say portfolio start date. I just put /portfolio starting date. So I call it stock start date and set it equal to 2013 01 01. Okay, and I'll run this cell. And let's go ahead and create a new cell. And I basically chose that date for Facebook because I believe that that was the first full year for Facebook was in 2013. So that's why I chose that that year and that starting date. All right. So let's go ahead and get the ending date that we want, which will be whatever today's date is. So let's get the stocks ending date, which is today. So I'm gonna create a variable called today and set it equal to datetime.today. All right, and then we need to format this variable. So just type string f time, and let's see, percent capital Y dash percent lowercase m dash percent d, and that should look good. Let's go ahead and see what it looks like now to make sure it's in the right form. All right, so it's definitely in the right form, so it looks good. Let's go ahead and create a new cell. And in this cell, we're going to create a data frame. And we're going to create this data frame to store the adjusted close price of the stocks. All right, so I'm going to create a variable called df, which of course will be short for data frame. And I'm going to set it equal to pd.dataframe. All right, so now we have our data frame object. Next, we're going to store the adjusted close price of the stock into the data frame. All right, so I'm going to use a loop. So for stock in our assets, I want df stock to be equal to web.dataReader. Okay, and we're going to input the stock and we're going to choose a data source. So we're going to choose Yahoo for the data source, and then we're going to give it a start date, which will be our stock start date, and then we need to give it a end date, which will be today. And again, we are returning the adjusted close price. Okay, so let's go ahead and run this cell. All right, let's create a new cell and let's take a look at that data frame. So here we're going to show the data frame, or I just put df. So just type df here and let's run this cell. All right, and now we can see our data frame with our adjusted close values for each stock that we have. Okay, so let's go ahead and create a new cell. And what I'm going to do here now is I'm going to visually show the stock / portfolio. All right, so let's give this graph that we're going to create a title. So I'm going to create a variable called title and set it equal to portfolio adjusted close price history. Okay, now let's get the stocks. So although this part right here, or this step is not really necessary, I'm going to call it my stocks, and I'm going to set it equal to df. And I misspelled my stocks, so let's get rid of that F there. All right, that looks good. And now let's create and plot the graph. So I'm going to bring this cell up a little bit more so I can see it a little bit better. Okay, so I want to loop through all of the columns in the data frame. So I just call it C in my underscore stocks dot column dot values. I want to plot each of these values. So I want to plot my underscore stocks for whatever that column name is. So the column name is C, and then we're going to give our plot a label. It will be the name of the column. Okay, so we're going to plot each of those stocks, and then let's go ahead and set our title. So just type plt.title, and then we're going to input title, which we created up top. And then we need to give our plot in a label on the x-axis. So just type plt.x label, and I will call that x-axis the date. And let's give it a font size. We'll give it a font size equal to 18. And next, let's give our y-axis a label. So I will call it the adjusted close price, or let's do adjusted price in USD, and then put a nice little $sign. Okay, and let's give it a font size as well. Okay, that looks good. Next, let's give our graph a legend. Okay, so we're gonna give it a legend. So it's gonna be my stocks dot columns dot values, and we're gonna put it in the upper left location. So just type lock equals and then upper left. All right, and then last but not least, we're going to show this graph. So hopefully everything is pretty good. Let's run the cell. All right, looks like I made a mistake. So let's see, data frame object has no attribute column. Okay, so my stocks dot is probably columns with an S, and let's run this. Okay, so this is the graph that we get back, and it looks pretty good, looks decent. All right, so we can see our title up top here. We can see the x-axis label and the y-axis label here. So let's go ahead and create a new cell. Yeah, let's go ahead and create a new cell. Actually, let's look back at this graph again. You can see right here in 2020, you can see the stocks are actually going down. Okay, and you can see the most expensive stock in this portfolio is Amazon. All right, and the least expensive seems to be Facebook down here. All right, so anyways, let's go to this new cell. Okay, so now in this cell, I want to show the daily simple returns. So let's go ahead and put that in comments here. Show the daily simple return. So I'm going to create a variable called returns, and I'm going to set it equal to df dot percent underscore change. Okay, and then I want to show the returns. So I'm just going to type returns here, and let's run this cell. And the returns is calculated by taking the new price divided by the old price and then subtracting 1. That's at least one way to do the formula. There's also another formula, but they're both equivalent. So here we get the daily returns for our stock. Okay, so next we're going to show the annualized covariance matrix. So let's go ahead and create a new cell here. And I put in comments that we're going to create and show the annualized covariance matrix. Okay, so in order to do this, let's create a variable called cove underscore matrix underscore annual and set this equal to returns dot cove. And then we're going to multiply it by 252, which is the number of trading days for this year. And for those of you who don't know what covariance matrix is, well, it's just a mathematical concept which is commonly used in statistics, and it basically determines how much two random variables vary or move together. So it's the directional relationship between two assets or two asset prices. All right, and let's go ahead and show the matrix. So let's run this cell. Okay, and then what are we looking at here? Well, on the diagonal line here, we are looking at something called the variance, and all the rest of the entries are called the covariance. All right, and variance is basically a measure of how much a set of observations differ from each other. Okay, and if we take the square root of variance, we get volatility. All right, so let's go ahead and create a new cell. Okay, and in this cell, I want to calculate the portfolio variance. All right, so how do we do that? Well, first I'm going to create a variable port underscore variance, and I'm going to set this equal to, well, we have to use a formula here. We need to take the weights transposed times the covariance matrix times the weights. All right, so that probably sounded really complicated, but it's going to be this simple here. Just type np dot, and then we're going to input weights dot t, so that's weights transpose, and then np dot, and then we're going to input our covariance matrix that we just created up top, and then input the weights again here. Okay, and I want to print the portfolio variance, so just put that there, and let's run the cell. Okay, so now we see the portfolio's variance, which is 0.0546308863, and then some more numbers behind there. All right, let's go ahead and create a new cell. And in this cell, I want to calculate the portfolio volatility. Okay, also known as the standard deviation. Okay, so like I said earlier, volatility is just the square root of variance. So let's just do that. So I'm going to create a variable called port underscore volatility, and I'm going to set that equal to np dot square root, and we're going to take the square root of the variance that we just created up top. So that's port underscore variance, and then let's show the portfolio's volatility. So let's run this cell. Okay, and this portfolio's volatility is 0.233732510. Let me see, 0.233732510. Yeah, and there's some more numbers behind it. So let's go ahead and create a new cell. And in this cell, let's calculate the annual portfolio return. So calculate the annual portfolio return. Okay, so I'm going to create a variable called portfolio simple annual return. Okay, and I'm going to set that equal to np.sum, and we're going to sum the the mean of our returns. So returns dot mean multiplied by the weights. Okay. And then of course we're going to multiply this by the number of trading days in the year, which is 252. And then I want to show this calculation. So I'm going to type portfolio, simple annual return, and let's run this cell. Okay, so we get 0.3201850376120795. All right, so let's go ahead and create a new cell, and let's kind of put this all together now to show what we're really calculating here. So here I'm going to show the expected annual return. I'm going to show the volatility, and I'm going to show the variance. And what is volatility, right? So volatility is also known as risk. Okay, so let's go ahead and create a few variables here. So I'm gonna make these all percentages. So I'm gonna create a variable called percent underscore var, which will be short for percent variance. And I'm gonna set this equal to string. We're going to round the portfolio variance 2 places and multiply this by 100. And then we're going to append the percentage sign to this string. All right. Okay. Next, let's create percent underscore vols for volume. I'm sorry, for volatility, not volume. And I'm going to set this equal to string round. And then we want to round our port volatility. And we want to do that 2 places. And let's multiply this by 100 and then append that percentage character. All right, so let's see what else we have. We have our portfolio simple annual return. So I'm going to create a variable called percent underscore RET, which would be short for percent return. And we're going to have string, and then we're going to round that number, that portfolio simple annual return 2 places. And then let's multiply this by 100. And then we will append that percent character again. Okay, so now let's do some print statements here. So the expected annual return of this portfolio that we have of our FANG stocks will be percent underscore RET. All right, next we want to print the annual volatility or risk, right, which is also the standard deviation. So that's percent underscore vols. And then I want to print the annual variance. All right, that's the percent underscore var. So hopefully I have everything correct. Return vols for volatility, not volume. I probably should rename that because I keep thinking volume here for some reason. And then percent var for variance. All right, so let's go ahead and run this cell. Okay, so that looks pretty good. So with this portfolio and the current weights that we have, which is 20% for each of the stocks in our portfolio, we have 20% of each. So the expected annual return is 32%, and the annual volatility or risk is 23%, and the annual variance is 5%. Okay, so that's really not bad, but I think we can do better. I think we can get a higher return for a lower risk. All right, so we're going to have to adjust our portfolio. And there's a great package, a great Python package that can help us with this. So let's go ahead and create a new cell and let's install that package. So just type pip install py portfolio opt. All right, and run that cell. And this will install this package for us. Okay, and it's done. So now let's scroll down and let's create a new cell. And in this cell, we're going to import the library. So from py pf opt dot efficient frontier, we're going to import efficient frontier. And then from py pf opt, I'm going to import risk underscore models. All right, next from py pf opt, I'm going to import expected underscore returns. All right, so let's go ahead and run this. All right, that looks good. And now what we're going to do is some portfolio optimization. I'm going to put an exclamation mark there. All right, so let's go ahead and calculate the expected returns and the annualized sample covariance matrix. And I put asset returns. All right, so I'm going to create a variable called mu, which, you know, in mathematics, mu usually stands for the mean. So mu is equal to expected underscore returns dot mean underscore historical return. And then I'm going to input the data frame that we're using here. And then I'm going to create a variable called s, which will contain the risk underscore models dot sample underscore cove, and we're going to input df. So now we're getting the sample covariance matrix and storing it into our variable s. All right. Next, I'm going to optimize for maximal Sharpe ratio. So here I'm going to put optimize for max Sharpe ratio. All right, and this is the Sharpe ratio is basically a way to describe how much excess return you receive for some amount of volatility, or for the, yeah, I guess for the extra amount of volatility that you get. And basically this ratio was created from William Sharpe back in 1966, And I guess a better way to say this is it measures the performance of an investment compared to an investment that is risk-free. So compared to investments such as bonds or treasury bills. All right. So again, it's pretty cool actually. I really like it. You guys can look up more information about it. I will have a link for a lot of these terms that I'm talking about in the description below, so you guys can check it all out. Don't just take my word for it for these different meanings and things. Look it up yourself as well. Okay, so yeah, let's optimize for max Sharpe ratio. All right, so I'm gonna create a variable called EF, and I'm gonna set this equal to the efficient frontier. And we have to input some variables here. So we're gonna input mu and s. All right, so now we've just created our efficient frontier object. I'm gonna create a variable called weights, and I know we created weights up top, but that's okay. I'm gonna create it again here. Weights is gonna be equal to EF dot max underscore Sharpe. So what we're doing here is we're maximizing the Sharpe ratio, and then we are getting the raw weights. Okay. Then I'm going to create a variable called cleaned underscore weights, and I'm going to set this equal to ef dot clean underscore weights. And what this is basically a helper method to clean the raw weights, and it sets any weights whose absolute values are below some cutoff. Uh, The cutoff is defaulted here in the method, but you can input your cutoff as well into this method. And then what it does is it, once it changes those values to 0, it then rounds the rest of the values. All right, so there may be some rounding error when we're done with this. I hope that's not too complicated. Anyways, let's go ahead and continue. So what we're going to do is we're going to print the cleaned weights. And then we're going to also return and show the expected return, the volatility, and the Sharpe ratio. So just type EF dot portfolio underscore performance. And we're going to set verbose equal to true. All right. So everything looks good. And you know what? I can probably simplify this clean weights thing. Basically, it's going to get rid of the stocks that we don't need to optimize our portfolio. It's kind of like that. All right, by doing some rounding. All right, so let's go ahead and run this. Okay, and what we can see here, I printed the weights for each of the stocks in the portfolio, and you'll see that Google's stock weight is 0, right? So it's telling us that we don't even need Google here. But if we add these numbers up, Um, ideally, it should be equal to 1, but because of that rounding that we do with the clean weights, it may be off by a little bit. But anyways, let's go ahead and take a look at this. We can now see that our expected annual return is 37.6%, and the volatility is 26.3%, which is better than what we had before. So before we had a expected return of 32% and a volatility of 23%. So our expected annual return actually went up. Our volatility actually went up as well, but we're getting more bang for our buck is what I would say, right? So this is a more optimal portfolio. I thought maybe we could lower the volatility and have the expected annual return go up, but that doesn't seem to be the case for this example here. All right, but that's not a problem. That looks good. I want to actually add up some of these numbers here. So let's see if this does equal 1. I'm just going to highlight them and paste them here. Or at least they should be close to 1. All right, let's see. Plus that, and then last but not least here, we can add that. Let's run this. All right, so yeah, I figured there would be some rounding error. So really, ideally, it should equal 1, but these equal 1.00001. Yeah, not bad. But let's go ahead and create a new cell. And what we're going to do now is we're going to get the discrete allocation of each share per stock. All right. So we're going to be using the same package. So from py-pf opt dot discrete allocation, I'm going to import discrete allocation and also get latest prices. All right, so I'm gonna create a variable called latest underscore prices and set it equal to get underscore latest underscore prices. And we're gonna get those prices from our data frame. And then let's create our weights again. So we're gonna set weights equal to cleaned weights this time. All right, so that's all these weights here. All right, and then we'll create a variable called DA, which will be short for discrete allocation. And we're going to set this equal to discrete allocation. And we're going to input weights, and we're going to input the latest underscore prices and the total portfolio value. So this will be the amount of money that we're willing to put into this portfolio. So I'm going to put in 15,000 US dollars. All right. And then we're going to create a variable called allocation and leftover and set it equal to da dot lp underscore portfolio. All right. And then let's print those two variables. So we're going to print discrete allocation, which will be allocation. And then we're going to print funds remaining. And I'll put the $ here, and we'll format this. So put $ colon two numbers after the decimal place. It's going to be a float, right? And then we're going to format this, dot format. So it's going to be a leftover. So let's go ahead and run this. All right. So now what this tells us is that given the amount of money that we're willing to put into this portfolio to optimize it, we can buy right now as of today, but today's actually the weekend, so I really can't buy anything because the stock market's closed. But we can buy 14 shares of Facebook, 2 shares of Amazon, 13 shares of Apple, and then 16 shares of Netflix. And after we have bought all these shares, we would then still have $51 and about 67 cents remaining. So that's basically it. I will leave a link to uh, all of the sources that I use to create this program, so you guys can get in the description below. And I'll also put in the description an article on this, what we did just now, so you can check that out as well. And if you guys like this video, please subscribe and hit that like button. And if you think it was helpful, please share it. And as always, thank you all for watching, and I'll see you all in the next video.